Now, in previous class we discussed about the problems in force and laws of motion. But in this chapter we made one mistake in last video. One problem will be some answer will be make wrong. That is, some calculation must be wrong there. So some students will be asked me, sir, this addition or subtraction is some doubt. So that's why again I am explaining that problem. Okay. So there actually some calculation part will be, some problem will be there on that day. So that's why again I repeat that problem. What is that problem? So in previous class that problem will be there. Just I will read that problem and make an answer. Okay. So previous video I had checked for question. What is that? Two objects of masses 100 grams and 200 grams are moving along the same line and direction with velocities 2 meter per second and 1 meter per second respectively. They collide, and after the collision the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object. That is the question. So in this question, what you have to make? Application or substitution all will be wrong, but in calculation part somewhat mistake will be done. Now I have to rectify that defect. Once again we recall the formula. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That's the application. In this, m1 is equal to, m1 is given as 100 grams. m1 is given as 100 grams. So remember that m1 value will be 100 grams. 100 grams. So that 100 grams to convert into kilogram, 100 by 1000, 2 zeros gets cancelled. So write 1 by 10 kilogram, 0.1 or 1 by 10. It is better to keep fraction. m2 is equal to 200 grams, that is equal to 200 by 1000, 2 zeros, 2 ones are 2 5s are. That is equal to 1 by 5 kilogram for m2. Now u1 is given as, u1 value will be given as, what is initial velocity? Initial velocity will be given as 2 meters per second. 2 meters per second. And u2 is given as 1 meter per second. v1 is given as 1.67 meter per second, and v2 is equal to how much? That is the question. So that we have to calculate the v2 value. Now once again recall the formula. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now in this m1, 1 by 10 into u1 is how much? 2 plus m2 how much? m2 1 by 5. 1 by 5 into u2, 1 is equal to m1 is 1 by 10 into 1.67 plus m2 1 by 5 into v2. 1 by 5 into v2, that v2 value I have calculated. Here 2 1s are 2 5s are doing calculation. Now what do you get? 1 by 5 plus 1 by 5 is equal to 1 by 5 plus 1 by 5 is equal to 1.67 by 10. This value 1.67 by 10 plus 1.5 v2. 1.5 v2. Now take LCM for these two first. 5. 1 plus 1 is equal to, you know this LCM? No. So 5 is the LCM, 1 plus 1 is equal to, here to take LCM, 10 is the LCM. 10 is the LCM for these two. Now 10 ones are 10, so 1.67 plus 5 ones are, 5 twos are 2v2. 2v2 AV. Yes? Now what do you get? 2 by 5 is equal to 1.67 plus 2v2 by 10. So by making cross multiplication, to make the cross multiplication, what do you get? 10 is equal to 5 into 1.67 plus 2v2 plus 2v2. Now 5 7s are 35. 5 3 6 are 30. 30 plus 3 33. 5 1s are 5. 5 plus 3 8. So 8.35 plus 2v2. What is this? 20. Now send that 8.5 this side. So 20 minus 8.35. Now to make some fraction, 20 minus 8.35. So 0.00. So 5 and 5, 9, 6, 9, 1, 1. So what do you get? So this is equal to 2v2. This value will be 2v2. Now what do you get? 5 2s are 10. Sorry. Let to open 5 2s are 10. 10v2. 5 2s are 10v2. Now what do you get? 11.65 is equal to 10v2. Now v2 is equal to 11.65 by 10. That is equal to 1.165. 1.165 meter per second. This is the answer. So in previous class, sorry, I made a mistake. So for making here some multiplication problems will be there in previous video. Please check this for this problem and share to correct this. Okay. So 1.165 meter per second is the value of V2. Okay. This about this one. Right. Now next I have to continue the another problem. So understand this one. So just in calculation part only made mistake. So somebody will correct, but somebody will ask. That's fine. So I observed that some mistake will be done in this calculation part. So once again I repeat this problem in this class. Okay. Now let's consider another problem. Next question. I have to take. So in this, so I consider. Just wait 1 minute. Yes, let's see. Next problem will be a truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if mass is 7 tons. Here 1 ton is equal to, remember that, 1000 kilograms. Ton to convert into kilograms. So that 1 ton means 1000 kilograms you have to consider. Here 7 tons will be given, means 7 into 1000. So 7000 kilograms will get its mass. So here, what is that? A truck starts from rest. So question will be a truck starts from rest. So from rest means what? Initial velocity becomes 0. That to remember in your minds. So starts from rest and rolls down a hill with a constant acceleration. Rolls down a hill with a constant acceleration. With a constant acceleration. Now it travels a distance of 400 meters. It travels a distance of 400 meters in 20 seconds. So time will be given as 20 seconds. In 20 seconds, find its acceleration. Find its acceleration. Find its acceleration and find the force acting on it, and find the force acting on it. Find the force acting on it. If its mass is given as acting on it, if its mass is 7 tons. If its mass is given as 7 tons, that's the clue. So first of all, we can calculate the acceleration. So acceleration, for calculating the acceleration, distance time will be given, initial velocity will be 0. So distance, time, initial velocity will be 0 will be given. So how to say it is 0? It starts from rest. That's why u is equal to 0 will be given. From, what is the equation for that? So we have to consider equations of motion also. And not only for F is equal to ma, F is equal to m into v minus u by t, like that application. In this, to consider these distances or otherwise velocities, which things will be given in equations of motion, we can apply that one also. So here first we can apply the equation S is equal to ut plus half at square. So by that application, first we calculate the a value, then afterwards we can calculate f is equal to ma value. Okay. Now here a track starts from rest. A track starts from rest. So initial velocity. So its initial velocity u is equal to 0. Distance traveled S is given at 400 meters. Time taken t will be given as 20 seconds. Now acceleration a is equal to how much? So substitute in the equation, s is equal to ut plus half at square. What is this value? 400 meters. 400 meters is equal to 0 into 20 plus half into a into 20 into 20. 20 into 20. T square or 20 into 20. 2 ones are 2 tens. So 0 into anything will be 0 plus 20 into 10 means 200 a. So here 400 distance will be given. Now a is equal to 400 by 200. 400 by 200, because 200 a is equal to 400, then a is equal to 400 by 200. 2 zeros cancel. 2 ones are 2 twos are. Now a is equal to 2 meters per second square. Therefore acceleration acts on the track will be 2 meters per second square. Then what is the mass given? What is the mass given in this question? 7 tons. 7 ton means 1 ton is equal to 1000 kgs. So what's the clue? To remember, 1 ton is equal to 1000 kilograms. Now here mass of the truck m is equal to 7 tons. So that is equal to 7 into 1000. 7 into 1000 means 7000 kilograms. 7000 kilograms is its mass, and acceleration will be 2 meters per second. Then force acts on the truck. F is equal to how much? Now F is equal to mv. That is equal to m 7000. M value 7000 into 2. Now that is equal to 7 14, 3 zeros. So newtons. F is equal to 14,000 newtons force will be acts on the track. Okay, understand? So here first, in previous chapter equations of motion, equation to be considered, from that to calculate its acceleration. So for given data, to remember that according to the data, we can apply these equations of motions. Okay, na? So after that only, after finding this acceleration only, you can calculate the force. So 14,000 newtons force will be acts, right? Understand this one. So first of all, to calculate its acceleration, then afterwards you can calculate the force, right? Now next problem to be continued.